Okay, so for this problem, we are told to find the Thevenin equivalent circuit at the terminals of resistor R1, and then find R1 for maximum power transfer. That's easy if we found the Thevenin resistance and the maximum power that can be found. Okay, so of course, it has a dependent voltage source, because that means we can't find the resistance using resistor simplification, which is sad, but that's how it is. But anytime you're going to find a Thevenin equivalent, you always have to find V open circuit. So we'll start with that. So V open circuit means I look at the open circuit at where I'm supposed to be finding the Thevenin equivalent circuit. So I make that open. And this is 1 kilo ohm, and this is 1 kilo ohm, and this is 1 kilo ohm. This is 2Vx. Okay, so I do know that whatever the voltage is here, and Vx is the voltage across this resistor, whatever the voltage is here, the voltage on the other side of this has to be 2Vx more than whatever it is here. I don't know this voltage yet, but I'm about to get there, and it's not so bad because when this is open, the current flows like this. So just simply like that, through 3 1 kilo ohm resistors, which are all identical. Since they're all identical, the voltage has to drop the same amount across each one of them. And you could do this using KVL. You could find the current and figure out what it is. But this is just saying that, I start at 2 volts here, and KVL says when I come back here, I'm going to be at 0, and then as I bump across here, I get back to 2. Well, it's going to fall by 1/3 across each one of these. And so if 1/3 of 2 is 2/3. And so I'll drop by 2/3. If I'm 0 right here, then right here I'll be 2 minus 1/3 of 2, or 6/3 minus 2/3 is 4/3. So I'd be at 4/3 volts right here. Then across this one, I'll drop another third of 2. So this would be 4/3 minus 1/3 of 2, or 4/3 minus 2/3, and that would be 2/3. And then I drop my last 2/3 down here. So I know that when this is open, if I make this ground, I'm at 4/3 volts right here, and I'm at 2/3 volts right here. That tells me, since this was ground, that Vx is 2/3 volt. Because this is 0, this is 2/3. 2/3 is 2/3 more than 0, so Vx is 2/3. That means that 2Vx is 4/3, and that the voltage right here has to be 4/3 more than it is on this side. On this side is 2/3, so on this top side it has to be 4/3 more than that, or it has to be 6/3 or 2. So what I have learned now is that in this circuit, right here, I am at 4/3 volts right here and 2 volts right here. V open circuit is the voltage difference across those two places. So V open circuit is 2 minus 4/3, or 6/3 minus 4/3, or 2/3 volts. So V open circuit is 2/3 volts. So I've done half of my Thevenin equivalent. The other half is to find R Thevenin. And boy, do I wish I didn't have a dependent source, because if I didn't have a dependent source, I could just do resistor simplification. But I do have a dependent source. And so what I do is I will deactivate all of my independent sources. And when you do that, you turn voltage sources to shorts and current sources to open. But I have to leave my dependent source. I will have my dependent source is two Vx my voltage source is just going to become a short. And I'm going to use the external source method just because that's what I'm most comfortable with. There is no good way of doing it when you have a dependent source. Now, I'm going to make my external source, so V external, I put it in this polarity, which would mean that the current that I'm going to be looking for, I external, would be going from minus to plus. You don't have to do it that way. You could do it the other way, and then you'd be looking for the current in the other direction. I just liked it that way because that way these two were had the same direction. And then I did a mesh analysis, because what I'm looking for, R Thevenin, equals V external over I external. So that's what I'm trying to find, is R Thevenin. I call this one I1, and I'll call this one I2. And as I do my mesh for I1, as I go into the negative terminal of the dependent source, oh, and by the way, this was Vx right here. Okay, so as I go into the negative side, I'll write negative 2Vx, and then I go into the negative side of my external source, minus V external, and then plus, here I have a shared resistor, so that'll be I1 minus I2 times 1 kilo ohm equals 0. So that's my top mesh equation. So my top mesh, minus 2Vx minus V external plus 1K I1 minus 1K I2 equals 0. Now my bottom mesh, I'll start by going through this 1 kilo ohm resistor, so it'll be 1K I2 plus, and then I have the shared resistor, so that'll be I2 minus I1 times 1 kilo ohm. And then I have this last one here, plus 1 kilo ohm times I2 equals 0. So this gets me 1K I2 plus 1K I2 minus 1K I1 plus 1K I2 equals 0. Or this one is 3K I2, yeah, I2. 3K I2 minus 1K I1 equals 0. Now I want to look at my Vx. So I notice that Vx has just I2 running through it. And so if I call this side 0 and this side Vx, then I can say that I2 equals 0 minus Vx over 1k, or Vx equals minus 1k I2. So I can plug that in to this one, and I get minus 2 times minus 1k I2 minus V external plus 1k I1 minus 1k I2 equals 0. This is plus negative 2 times negative 1 is positive 2. So 2k I2 minus V external plus 1k I1 minus 1k I2 equals 0, or 1k I1 plus 1k I2 equals V external. So now if I take this equation and this equation, then I will have 1k I1 plus 1k I2 equals V external, and negative 1k I1 plus 3k I2 equals 0, or 4k I2 equals V external. Or, if you recall, what I was looking for was, for my Thevenin equivalent, I need, where did I write it? I don't know where I wrote it, but R Thevenin equals V external over I external. Well, let's take a look at I external and see what it is. I external is I1, so we'll come back to that in a second. So I2 or V external over I2 equals 4k. And I think, what did I do there? I just plugged in. Oh no, okay, so I solved for I2. So I2 equals V external over 4k, and then I will plug that into this one. So 1k I1 plus 1k times V external over 4k equals V external, or 1k I1 equal plus 1/4 V external equals V external, or 1k I1 equals 3/4 V external, or I bring the 4/3 over here. 4/3 times 1k equals V external over I1. And my k seems to be in the wrong place. No, it's not. That's right. Okay. So I wanted R Thevenin to be V external over I external. This is R Thevenin. So R Thevenin is 4/3 times 1,000, or 1333. ohms. So that's our Thevenin. So our Thevenin equivalent circuit has our V open circuit, which was 4/3 volts, times our Thevenin resistance, which was 4/3 K ohms. And that is our Thevenin equivalent circuit. Now it says that was part A. Part B says find R Thevenin for maximum power, or R1 for maximum power transfer and the maximum power that can be transferred. Okay, so you have maximum power transfer when your load resistance equals your Thevenin resistance. And so we would want R1 to equal 4/3 kiloohms. So that gives us maximum power. Now, so what resistance do you want for maximum power? You want 4/3 kiloohms. What is that maximum power? Well, we'll draw our Thevenin equivalent circuit. So this was 4/3 volts. This is 4/3 kiloohms. This is also 4/3 kiloohms. And we want to find what is this power. Well, power equals IV, and I know that V equals IR, or I equals V over R, so power also equals V squared over R. The reason I wanted that is I know what the voltage is across this resistor, because these two resistors are equal. And so the voltage across each of them has to be half of the total voltage. So the voltage across this resistor has to be 2/3 volts. It has to be half of the 4/3 volts. So the voltage across our Thevenin resistor has to be 1/2 times 4/3 volts, has to be 2/3 volts. So my power has to be 2/3 squared over my Thevenin resistance, which is 4/3 kiloohms, which is 4/9 times 3/4 over 1K, which is 1/3 divided by, I'm missing some, I got something wrong here. Where did I do my power? One-third volt. Did I have the wrong V Thevenin? V open circuit was 2/3. So V open circuit was 2/3. This was supposed to be 2/3. And so in my Thevenin equivalent circuit, that was supposed to be 2/3. It also means that the voltage drop across each one of these would only be 1/3, which would make this 1/9, which would make this 1/12 over 1,000, which would make this 0.083 milliwatts. So, any questions on that one? Oh, there was something in the chat. Could you find VOC's using KVL as well after. So I guess it was. Yes, you could, but after what?
Oh, I just meant like if you could show it when you're done.
Oh, could I find VOC using KVL? Oh, yeah. Oh, after, yes. When I'm done with all this, could I show using VOC? Yes, find VOC. Yes, I can do that. Okay. Any other questions? Okay, so let me go ahead and do that. So I will find VOC using KVL. So let me draw that. Whoops. Okay, so I want to use KVL to find V open circuit. So if I do a loop around here with KVL, that gets me minus 2Vx plus V open circuit. This was 1 kilo ohm. I'm going to say, what I'm going to do here is say that I know, because all of my current is flowing through this part right here, that my voltage drop across each of these resistors has to be the same. It has to be Vx for each of them. So, and let's see, what Vx is plus here and minus here. And so my voltage drop here has to be Vx. Let me see, is Vx a positive or a negative number? Let me think for a second. Vx is a positive number. So this would be trying to think of the convention we use here. This is plus, yeah. So this will be plus Vx. So in this loop, that would be plus, so all of these are all going to be, these are all going to be plus Vx is going to be their voltage across them. So that would be 0. And then, so that would tell me V open circuit equals Vx. So I have that. Now from this other loop, I would have plus 2 minus Vx minus Vx minus Vx equals 0, or 3Vx equals 2, or Vx equals 2/3. And so Vx equals 2/3, or V open circuit also equals 2/3. So that is a way to do it using KVL. So any other questions? Yep. Go ahead. What was your question? No?
Me? I was just saying thanks.
Oh, you're welcome. Any other questions? Nope. All right then. That is all I can do tonight. I'm all circuited out. I'm going to stop this and I will post it. And if y'all have any questions over the next few days, please feel free to email me. I'm going to be really busy Wednesday, which I know is the day most of y'all are going to be studying. I'm going to be taking exams all day long. So if you have questions, you're best off trying to get them to me before Wednesday. So, all right. Good luck, everybody.